According to the National Electrical Code, running circuits through a panel to reach another panel is not explicitly prohibited. Section 300.15 states that conductors shall not be run through or within the hollow spaces of walls, ceilings, or floors, except as permitted by this code. However, there is no exception specifically addressing this practice. While the NEC may not specifically prohibit this routing, it raises some concerns. Firstly, it can be confusing to have branch circuits entering and exiting a panel that is not intended to be a point of distribution. Secondly, if the panel is not designed for through wiring, there may be safety risks such as increased heat generation or arcing. Thirdly, troubleshooting and repairs may be more difficult if circuits are routed through multiple panels. Instead of running circuits through a panel, consider these alternatives. 1. Use a dedicated wireway. Install a separate wireway adjacent to the panel to route the branch circuits to the next panel. 2. Install a subpanel downstream of the first panel and use that as the point of distribution for the branch circuits. 3. If the two panels are part of a critical power system or need to be isolated for maintenance, use a transfer switch to switch between the two panels without running circuits through either one. It is recommended to discuss your concerns with the contractor and present them with the alternative solutions. Explain that while the NEC may not explicitly prohibit this routing, it is not considered best practice and could lead to confusion and safety hazards. Explain that the proposed alternatives would provide a more organized, safe, and maintainable system. For example, consider a situation where a 277-volt lighting circuit is fed from a 480W/277-volt panel. This circuit needs to supply power to lighting fixtures located near a second 480W/277-volt panel. The contractor has chosen to run the 277-volt conductors from the first panel through the enclosure of the second panel and then out to the lighting fixtures. While this might seem like a direct route, it creates several potential problems. Imagine a scenario where a technician needs to isolate the 277-volt lighting circuit for maintenance. The technician would need to access both panels to completely de-energize the circuit, potentially leading to confusion and increasing the risk of accidental contact with live parts. Alternatively, consider the increased heat generated within the second panel due to the additional conductors passing through it. If the panel is not designed to handle this additional heat load, it could lead to premature failure of the panel components or even create a fire hazard. Another issue arises during troubleshooting. If the lighting circuit malfunctions, it might not be immediately clear which panel is the source of the problem. This could lead to unnecessary delays and increase the time required to diagnose and repair a fault. A better approach would be to install a dedicated wireway between the two panels. The 277-volt conductors could then be routed through the wireway to the lighting fixtures without entering the second panel enclosure. This would provide a clear and organized wiring path, making it easier to identify and isolate the circuit for maintenance or troubleshooting. Another option would be to install a subpanel near the lighting fixtures. This subpanel could be fed from the first panel and used as the point of distribution for the lighting circuit. This would eliminate the need to run conductors through the second panel and provide a more localized control point for the lighting system. In situations where the two panels are part of a critical power system, a transfer switch could be used to switch between the two power sources without running circuits through either panel. This would ensure a reliable and seamless transfer of power in the event of a power outage or other emergency. By considering these alternatives and discussing them with the contractor, you can ensure that the wiring system is installed in a safe, organized, and maintainable manner, even if the NEC does not explicitly prohibit the original routing method. Always prioritize safety and clarity when designing and installing electrical systems. In addition to the previous points, consider the potential for future modifications or expansions to the electrical system. If the 277-volt circuit is routed through the second panel, it may limit the ability to add new circuits or make changes to the existing system. The additional conductors could take up valuable space within the panel enclosure, making it difficult to work on other circuits or install new components. A dedicated wireway or subpanel would provide more flexibility for future modifications, allowing for easier expansion and reconfiguration of the electrical system. Furthermore, consider the impact on the overall aesthetics of the installation. Running circuits through a panel can create a cluttered and disorganized appearance, especially if the panel is located in a visible area. A dedicated wireway or subpanel can help to create a cleaner and more professional-looking installation. When discussing these concerns with the contractor, it is important to be respectful and professional. Explain your reasoning clearly and provide supporting evidence from the NEC or other relevant standards. Be open to hearing the contractor's perspective and be willing to compromise if necessary. The goal is to find a solution that meets the needs of all parties while ensuring the safety and reliability of the electrical system. Also, document all discussions and decisions in writing. This will help to avoid misunderstandings and provide a record of the agreed-upon solution. Include drawings or diagrams to illustrate the proposed wiring methods and ensure that everyone is on the same page. Before making any changes to the wiring system, be sure to obtain the necessary permits and approvals from the local electrical inspector. This will ensure that the installation complies with all applicable codes and regulations. In addition to the technical aspects of the installation, consider the human factors involved. Think about how the wiring system will be used and maintained over its lifespan. Will it be easy for technicians to access and work on the circuits? Will the labeling and documentation be clear and accurate? By considering these factors, you can help to ensure that the electrical system is not only safe and reliable but also user-friendly. Regularly inspect and maintain the electrical system to identify and correct any potential problems before they become serious. This includes checking for loose connections, damaged wiring, and signs of overheating. A well-maintained electrical system will provide years of reliable service and help to prevent electrical hazards. In summary, while the NEC may not explicitly prohibit running circuits through a panel to reach another panel, it is generally not considered best practice due to concerns about confusion, safety, and maintenance. By considering alternative wiring methods and discussing these concerns with the contractor, you can ensure that the electrical system is installed in a safe, organized, and maintainable manner. Always prioritize safety and clarity when designing and installing electrical systems, and be sure to comply with all applicable codes and regulations. Furthermore, when evaluating the proposed wiring configuration, consider the long-term implications for the electrical system. Firstly, assess the potential for future load growth. Will the existing panel have sufficient capacity to handle additional circuits in the future? If not, consider installing a larger panel or a subpanel to accommodate future needs. Secondly, evaluate the accessibility of the panel and the wiring. Will it be easy for technicians to access the panel for maintenance and repairs? Ensure that the panel is located in a well-lit and easily accessible area. Thirdly, consider the environmental conditions in which the panel will be located. Will the panel be exposed to moisture, dust, or extreme temperatures? If so, select a panel that is rated for the appropriate environmental conditions. Fourthly, ensure that all wiring is properly supported and secured. Use appropriate cable ties, clamps, and conduits to prevent the wiring from becoming damaged or dislodged. Fifthly, label all circuits clearly and accurately. Use a permanent marker or labeling machine to identify each circuit breaker and the corresponding load that it serves. Sixthly, maintain accurate records of all electrical work. Keep copies of all permits, drawings, and specifications in a safe and accessible location. Seventhly, train all personnel who will be working on the electrical system. Ensure that they are familiar with the safety procedures and the proper use of electrical equipment. Eighthly, regularly inspect the electrical system for any signs of damage or wear. Look for loose connections, frayed wiring, and corroded components. Ninthly, promptly repair any electrical problems that are identified. Do not delay repairs, as this could lead to more serious problems in the future. Tenthly, consider the use of arc fault circuit interrupters, or RFCIs, and ground fault circuit interrupters, or GFCIs, to protect against electrical shock and fire hazards. ASIs and GFCIs are designed to detect dangerous electrical conditions and automatically shut off the power to the affected circuit. Always consult with a qualified electrician when designing, installing, or modifying an electrical system. A qualified electrician will have the knowledge and experience to ensure that the work is done safely and in accordance with all applicable codes and regulations. In conclusion, while running circuits through a panel may seem like a convenient solution, it is important to carefully consider the potential implications for safety, maintenance, and future modifications. By following best practices and consulting with a qualified electrician, you can ensure that the electrical system is installed in a safe, reliable, and maintainable manner.